Welcome to a new test and teardown video. I think this one is going to be a repair video because the guy who gave me this power supply told me it's defect and he couldn't be bothered to fix it, or he couldn't figure out how to fix it. It was something there in between that. So it's called a Sagitta and no type number other than that. I actually don't know how many volts and how many currents and whatnot it can do, but that is how it looks. Let's look at the back side, and this is all we see. We don't know any type numbers other than, see, here we see 2003 and here 2001, so maybe that is how old it is. This is just my best guess so far. So there's a fan and, yeah, super thin and flimsy metal here. Of course, it's super cheap product, I guess, but let's open this and see if we can figure out what's wrong. So let's look a little bit inside this unit here. Got a very big mains transformer, and it is located really nice in the middle of the unit for good weight balance. And the IEC mains input here is with an integrated fuse. So what they do is they just go directly to the transformer, main switch, done deal. So that's easy. And look at that. We got 4 2N3055s on a piece of aluminium. That is the cooling, so that they can really give you a lot of amps. And I see some relays here, so I think this is a like a step over from different windings depending on the output voltage. This is a good way to minimize the requirement of heatsink size. So you will have a very low voltage across the series regulator. The rest of this board looks very, very normal. Standard components. Should be quite easy to figure out what is going on here. And let's look a little bit. I'm trying to find the diodes. Is that really the tiny little diodes down there? D7, D6 and stuff like that. Is that really all? So, I mean, that's 1 amp diodes, right? But I am looking to see if I can find some bigger diodes, and I just can't. So that means those 4 big. Okay, we got a rectifier here, right? So that one will do a lot of amps. Okay, so that is probably how it works, right? So they will somehow use that rectifier, and then there's a capacitor down here, so that is how it is. You also got a little bias rectifier here and a little bias voltage, and then there is the display and metering kind of stuff here. We're just using a standard chip to do that. The 7107 will drive 7 segments and stuff like that. And I think there is actually, yes, there is another board under that one containing all the displays. And we got the pot meters down here. B1, okay, so that is 1K and 10K for voltage, and it's probably the same for, no, 5 and 50. Okay, so that is how it is. Let's power it up and see how much this is not working. So this will be my first power up on this device. Mains is applied, and if I hit 50 volts of output, and okay, that is probably the fault condition. Here is full output voltage, fantastic. And it's using 18 watts, so I better turn it off. So that is what I need to see if I can figure this out. As always, I love to cheat. If you look at that resistor here in the middle, it is still very warm. I just powered it up again. So that resistor just goes absolutely crazy. So that tells me I need to search in that direction. I was actually following the input voltage through a driver and then the output, and then I started to smell some bad stuff here. So and then where the heck what is getting warm, and it was in the middle of the PCB, so I couldn't really feel it so much from this side. But again, a thermal camera is just a super good cheat to get into the right area. So here's my attempt to figure out what was going on. The first thing I did was to remove the driver up here, because that will remove everything driving the output, and I still got 50 volts output. But I didn't see a complete short between the bases and the collectors of all the output transistors here. So what I've done now is the base signal, that is the yellow wire that goes around here, and then I now, when it's removed like that, right? And then I just measure from collector to base, and then one of them here, we got about 200 ohms both ways on that one, but not the others. So what I'm going to do, my first attempt is just to remove that one and see if it works with only 3 output transistors. I feel very confident about that. I found the bug about this shorted transistor, so I actually put in a new one, and I think it is okay to have, you know, different types here, because we're using quite high emitter resistors, so there is a local feedback here. That means the current sharing will still work between the 4 transistors. And here is a thermal switch that will turn on the fan when the heatsink gets very warm. I don't really like this approach, but anyway, this is how they done it. Up here we got 3 red wires for the mains entry, and one of them is of course chassis. I'll have to change this one to a green one. I don't really like using all reds. That is going to be a problem one day. So now I changed this transistor, and I think we are ready to power this up again. Boing. And what is this? I think we got variable voltage, so this is the fine part. Let's try and click, clack. Aha, so the pre-selector voltage here is also working. So all is maximum here, 29 volts. And voltmeter seems to be quite accurate, actually. Very, very impressive. Let's see if we can go all the way to 0, because that is always what is a problem. So it's get a little bit of unstable here, right? But what if we just give it... Oh, it looks quite unstable at low voltage. Maybe just a little bit of... Yeah. What exactly would you call that? Is that ripple? No, it's just unstable somehow. Let me see if it's... No. Well. Maybe that's just how it is. I will of course take a scope. But let's, I want to try and load it a little bit and see what kind of amps this thing can do. So I put a scope on the output, and let's have a look what happens when I adjust the voltage. So this is definitely pot meter noise. See? So there's a input, the set point, see? The set point from the potmeter isn't really filtered in any way. And like here, I am in a position of the potmeter, oops, and then it goes away. Some positions of the potmeter, it's just creating like this. And it just goes on and on for a little while, and then it goes stable. So definitely this one needs potmeter cleaning or new potmeters. But so far it seems to be working. Look at that. Noisy pots. So all we need to do now is to load it a little bit and see if we can what we can do here. So I will put it, oh, so it changes here in the middle. There's probably, oh, and there's another one here. Yeah, so we got, how many relays have we got? Only 2 relays, right? So the first one should be here, right? Click, clack, and then, okay. So we got 4 ranges with 2 relays, right? Okay, I found another problem. So I'm just loading it with 1 amp, as you can see here, and then I'm playing with the current setting. And look at that. Now it should go into constant current mode, but it's not changing the voltage or the amps or anything. Right, so this is all down to 0. It seems like it is responding to this somehow, right? But nothing gets done here. And then it goes in and out of constant current or constant voltage mode, as you can see here. Something happens, but well. Okay, so there's still a little bit to solve here. But let's just pretend. Okay, because I wanted to try and see what kind of amps I can load this. But of course, when current regulation or protection is not working, I could potentially blow this up by shorting the outputs or overloading it. So of course, I'm not gonna pull any more than 1 amp. So far, I need to solve this first. Of course, I managed to figure out the last details of this power supply. Let's have it like this so you can see what's going on here. So the problem with the current controller, or the part of this op amp that is handling current, that is this diode that of course pulls down the voltage setting. So when it's pulling down the voltage setting, it's using too much power and then destroying its own power supply. And that power supply was just a capacitor and a resistor that was on the other side, and that resistor here was blown up. So it was probably replaced with a wrong value that made the voltage regulation work. But of course this op amp can only handle plus minus 15 at its maximum. So I'm running it as plus minus 12. So I've added this little construction or constructive design modification, but that is actually what is needed to make it work. So here's a positive regulator, 12 volt positive, and that is the high side of this op amp. And here is the 3 pins, 3 wires from the transformer. The sensor of that goes to the output voltage. So all this copper here is output voltage. So whatever the voltage is, on top of that and below that, we have a plus minus 24 volt on a little rectifier here. So the positive, of course, goes to the 12 volt regulator, but the negative, it goes to the fan, but it just also went via a resistor and a capacitor to the 2 op amps. And that is of course a very, very bad way to do this, because whatever current you are using here, it must be super well trimmed, and when it is in current regulation, of course it will use a lot more current because it's pulling down the output voltage from the voltage control via the driver to the output transistors. So I had to go through more or less the entire circuit to figure all this out and what is doing what and how it works, until I could come up with a perfect design change for this. Also, I can tell you this is the maximum voltage adjustment and this is the maximum current adjustment. And of course, if you're real smart, you look at the PCB and then you see that this is an RXN-303DD, and that is easy to Google, but you can't find schematics. So I think this is more or less how the whole unit works. So what we can do is we can power it up now. So here we go. This is my maximum voltage. I've just adjusted that to just a tiny bit over 30 with both of them to the maximum. And current at absolutely maximum. I also adjusted this to 5 amps. So let's just give it current 1 amp. Let's see how it works. And I'm trying to go down here. It goes to current adjustment, and then I can of course say what kind of current I want, and then it goes in and out of current regulation. Isn't that just cool? And it almost goes to 0 as well. So now I've set the current regulation to maximum. So how about we just try and show you guys what is going on. And I got a load here that will do exactly 1 amp per step. So that is 5 amps, and that is a little bit annoying because I think I did set it. Oh, that is my fault. That was this one. Ah, man, I'm sorry about that little intermezzo. Now we're back at 5 amps. And yes, that is 150 watts output at its maximum potential. So, what do you think is the power consumption from the mains? Oy, oy, oy. Here we go, 269 watts. So, how long is it going to take before this one will blow up or start smelling? The fan regulation here is actually quite smart. There is this little switch, and it is set quite low. So when this one goes warm, it should definitely go warm in a few minutes. And then the fan will start to spin, and the fan is not really annoying or anything. Can we hear it? No, we cannot. Why can't we hear that? Yes, did you hear that? There was a click. Actually, a quite loud click. And then the fan is running. And that is it. It's not that bad. Alright, so I don't have a lot more to add. Yeah. There was actually one more thing. Oh, let's turn off the load. Then voltage rises and then the fan speeds up. How cute. There was actually one more thing to show you guys. And that was a little missing detail here. This diode here, a reverse diode on the output. I did not find this one in this design. And that is very important if you serious connect power supplies, or if you just do something stupid in your lab experiment or whatever you can do. I mean, this diode is definitely supposed to be there, and of course this must be able to handle more amps than this power supply can do. What if you have 2 of them in series and one of them is in current limits mode? Then you're going to reverse all all your available voltage directly into the other one, and it's probably gonna blow it up, right? Alright, thank you very much for watching. Bye bye. See what I've done here? That is actually one last experiment I think we should do. I painted the 4 transistors because remember one of them is new. So I painted all of them. As you can see here, they are of course the same color. So what I'm doing now is I started to load only 1 amp. And then we'll see if all of them get equally warm. If you look a little bit more here, I think I didn't put in enough paint here, so this is still a little bit shiny. So that can probably trick us a little bit. Yeah, look at that. It is very close to the same temperature, so that is not too bad. That will be the rectifier here. So there is a heat transfer kind of problem, right? This one is not transferring its heat to anything, but this very thin steel plate is not conducting heat very well. So you can see this is just heating up. So as far as I can see, all 4 transistors gets more or less the same temperature. So that is quite alright.